In this video, I'm going to talk about compound interest problems. So, compound interest problems deal with the compound interest formula, which is an exponential formula that stems from what we've learned about exponential functions thus far. So, exponential functions thus far, what we know is we know that A is our starting value, okay, is what we're starting with, and B is what we're multiplying by. So in this case, I'm going to call it the multiplier. Okay, and then X for compound interest formulas are normally in years in our case. Now, what's different about this formula than the formula that we've been using with exponential functions is the multiplier. The way we think about the multiplier is just slightly different. We still have our starting amount, so A is still the initial amount that we're investing in an account. However, we think of this multiplier in terms of two different things. If you recall what we know about exponential functions, when the multiplier is a 1, okay, so imagine in this parentheses I just have a 1. Okay, well if I take my starting amount times 1, I just get my starting amount back again. Okay, it neither grows nor decays, it stays the same. So 1 is like the neutral point, it's like the balance, it's where I just get my money back. Any additional amount would come from adding something to 1. So normally the formula looks more like this. It's our starting amount times 1 plus whatever rate it's growing at. Now, in our purposes, this rate will always be a yearly rate, and specifically we need to remember it's always as a decimal, not as a percentage. Okay, it's always in a decimal format, not as a percentage. All right, we're going to use this formula then to help us solve some of these problems. So looking at number 1, it says you invest $1,000 at 2.5% annual interest. How much will be in the account after 4 years? All right, we're going to use this formula. So it's going to be y equals my starting amount, because A is still my start. So I'm investing $1,000. Okay, I'm investing it at point or at 2.5%. So it's going to be 1 plus, but I don't want this as a percentage. I want this as a decimal. So you have to remember to divide by 100, and dividing by 100 really is the same thing as moving the decimal 2 places to the left. So we're really going to be taking 1 plus 0.025. And then we're raising that to the 4th power, okay? X represents our number of years. Okay, so our initial amount's 1,000, 1's our neutral point, but we're growing at 0.025 because we're growing at 2.5%, and we're doing that for 4 years. Now, to get the actual number, I can type this into a graphing calculator. Okay, so on my graphing calculator here, I'm going to type in this exact equation into the calculator. So I'm going to type 1,000 parentheses. Let me move this up so you can see me doing this. And then I'm going to put 1 plus 0.025. I'm going to close the parentheses. And then this little arrow button allows me to get an exponent. And I'm going to put a 4 there. Okay, so this is the same equation I had written down below. 1,000 as the starting amount times 1 plus 0.025 for 4 years. Hit enter, and it tells me it's going to be $1,103.81. So I just write that number down. We're going to have $1,103.81 in the account. All right, let's look at one final example here. So here I have you invest $5,000 at 4% annual interest. How much will be in the account after 9 years? So it's going to be y equals, I have the $5,000 I'm starting with. We're going to do 1 plus 0.04, because remember we have to move the decimal point's behind it. We move 2 to the left to make it a decimal instead of a percentage. And we're doing this for 9 years. Now, once again, I can just simply type this equation into my calculator. So in my calculator, I'm going to clear out what I put in there earlier. I'm going to type in 5,000 times 1.04, and then I'm going to raise that to the 9th power. And that gives me 7,116.56, if I round up, dollars in the account after 9 years.